Dear all, let us understand the new type of the approach, that is a machine learning approach called concept learning. So concept learning can be formulated as a problem of searching through a predefined space of potential hypothesis for the hypothesis that best fits the training examples. So here we are going to train the machine such that it is able to learn a concept. So prior to that, let us first understand what do you mean by hypothesis. Hypothesis is a proposed explanation made on the basis of limited evidence as a starting point for the further investigation. So it is a process of what the learning in a step by step. So initially we may not have the complete idea. So we have some prior assumptions. Then once we go through the understanding, that is the learning process, then what we are able to conclude whether it is correct or not. So the search can be efficiently organized by taking advantage of naturally occurring structure over the hypothesis space. A general to specific ordering of hypothesis. So in the concept learning, actually we will be observing how we can able to what fix the boundary. That is nothing but that is within that boundary will be about to take the decision making. That is we are able to learn the concept. So in order to learn the concept, so we are fixing the boundaries. That is nothing but what specific to generic boundary. And then within this boundary, you are able to specify the what, that is what actually we are able to learn within that. Concept learning is also referred as a Boolean valued function from the training examples of its input and output. So that is referring a Boolean valued function means here we are able to realize that whether we understood that concept or not. So based on that, we are able to what? Define the target. So now how actually we relate this concept learning as a task. So here in general, any concept learning task can be described by the set of instances. So the set of instances over which the target function is defined. What is actually the target function? Target function is the set of candidate hypothesis considered by the learner and the set of available training examples. That is, candidate hypothesis are those, nothing but what? The hypothesis not yet approved or proved. So it is initially with the assumptions, we come up with some statements, that is the hypothesis. And in the process of learning the concept, so we will come to know out of all these candidates, which will be the best fit hypothesis, or we can say the best fit, the hypothesis that best fit all the training examples. So let us understand that, that is once we go with the concept and the related problems. First, let us understand with the help of a concept called what? Enjoy the sport. So here we are able to learn that when a person can enjoy the sport or not, depending upon the conditions, that is nothing but the weather conditions. So you can observe here the days on which my friend enjoys the favorite water sport or the tennis, whatever the way, that is what about the concept, when actually they'll be able to what realize they can play the sport or not. So let us observe here, acquiring the definition of general category, a given example of positive and negative training examples of the category. So in order to learn the concept, so we should have the training data set since it is a category of supervised machine learning. So here we are feeding the positive and then negative outcomes, that is the targets, along with the different attributes with respect to a instances. Okay, so now what actually we are observing, so you can observe this sample data set. So here we have some 4 examples, or we can also consider these are the different weather conditions here with the attributes. Here the sky attribute, air temperature, humidity, wind, water, and forecast. At the last, we have a concept called the enjoy sport. And you can observe here, so these are referred as what? That is the column header are considered as the attributes. And if the every row related to that column header, what are all the values are there? So we refer it as what? Values related to that attribute. So an attribute can have more than one values. Okay, so the thing is how actually this will be help us to what? To learn about the hypothesis which best fit all the training examples. That is the hypothesis where we are going to prove that yes, the outcome is this or the outcome is not that one, so that we are able to what come to the conclusion. So we can observe here the set of example days, each represented by the set of attributes, and the major concept here is what? That is the enjoy sport. So now what is actually we are going to learn? To learn to predict the value of the enjoy sport for an arbitrary day based on the value of its other attributes. So we are actually learning what we are learning. We are learning the concept that when we can play the sport or not, depending upon the weather conditions. So we can observe here, let each hypothesis consist of a conjunction of the constraints on the instance attributes, and each hypothesis be a vector of 6 constraints specifying the values of 6 attributes. Please observe here the sky, air temperature, the humidity, wind, water, and forecast. So now for each attribute hypothesis will either indicated by a question mark that indicates any value is acceptable for this attribute. Means the question mark, whenever we encounter the question mark, it is nothing but any value can be acceptable. And then guys, there is also one more consideration, that is when we are not considering any value and then we are considering with the any value, or what you can do, we can actually specify about a value. So let us first understand what do you mean by hypothesis. That is each hypothesis described by a conjunction of the constraints on the attributes sky, temperature, humidity, wind, water, and the forecast. So here let us understand the concept of the hypothesis and the concept learning with this example. The constraints may be the question mark. I have already told you that is any value is acceptable, or with the phi symbol, that is no value is acceptable, that we usually refer it as the null. Okay, so or we can also consider it as what? A specific value. And here we are going to define that this target concept as a Boolean function, and you can observe here it is related to the what? The two values, that is the true, false, true, that is the true and false, that specification. And the training examples, that is represented by the letter D, which indicates the positive and negative examples of the target function, that is as per the table. So we can go with the table here. So here all the yes, what we can say, the values are considered as the positive example and no is considered as the negative example. So now let us understand how actually we are able to go through this problem. So let us determine a hypothesis H in the hypothesis space such that H of X is equal to C of X for all X in X. It indicates what? We are going to find a hypothesis that best fits all the training examples. So now we can observe here the learner is presented a set of training examples, each consisting of an instance X from all the instances along with its target concept value C of X. So now we already know that since it is a Boolean valued function, we are able to determine that as instances for which C of X is equal to 1, that is are the positive examples, and the members of the target concept, positive members, and the instances for which C of X is equal to 0 are called negative examples, also called non-members of the target concept. So now first realize this, what is concept learning as a search? The concept learning can be viewed as the task of searching through a large space of hypothesis implicitly defined by the hypothesis representation. So here what actually we are going to do, so there will be n number of what the candidate hypothesis will be there. So out of that, which will be the best hypothesis which fits the training examples. So now we can observe here how to represent this and then how we are able to apply this to the particular data set, that is the label set, and then how we are able to the end up with the hypothesis which best fit the examples. So now we can observe here that is depending upon the requirement. So we'll be defining some of the the observations over there, and then we will also see how to define the hypothesis. That is nothing but the conjunction of the instances related attributes.